More than 90% of the UAE's territory is desert, with summer temperatures in some places exceeding 50 degrees Celsius and almost not enough fresh water for farming. Yet this very dry land is gradually rising to become one of the world's most ambitious high-tech agriculture hubs. From seawater desalination systems, a giant vertical farm near Dubai Airport, lush green date palm gardens, to smart greenhouses in the middle of the Abu Dhabi desert, the UAE is opening up a new path for desert agriculture. So how has the UAE done it? Let's explore it with Terran Works in today's video. The UAE is a country located in the southeastern part of the Arabian Peninsula, with an area of about 83,600 kilometers and is made up of 7 emirates: Abu Dhabi, Dubai, Sharjah, Ajman, Al Quwain, Ras Al Khaimah, and Fujairah. Among them, Abu Dhabi is the capital, as well as the most important oil and gas center, known for its oil resources, massive investment funds, and strategic seaport system. Dubai, meanwhile, is seen as the modern face of the country, a global symbol of finance, trade, aviation, tourism, and luxury real estate. Thanks to its strong economic resources, the UAE has risen to become one of the richest and most ambitious countries in the Middle East. In 2025, the country's GDP reached about 517 billion USD. However, behind that glamorous image is an extremely harsh natural challenge. More than 80% of the UAE's area is desert. Average rainfall is only about 100 millimeters per year, and there are almost no stable natural rivers or lakes. Arable land accounts for less than 1% of the country's total area. Not only does the UAE lack land, it is also among the most water-scarce countries in the world. Most agricultural production has to rely on groundwater, while the extraction rate is much higher than the natural recharge capacity. Because of these limitations, the country still has to import about 80 to 90% of its food needs. To maintain agriculture in the middle of the desert, the UAE cannot rely only on its limited natural water sources. The country has to operate a massive artificial water system, combining seawater desalination, groundwater extraction, and treated wastewater reuse. This is a network that requires large investment costs, consumes a great deal of energy, and must be managed with extreme precision. Along the coast of the Persian Gulf, large-scale desalination plants are turning seawater into fresh water using seawater reverse osmosis technology, in which water is forced through high-pressure membranes to separate salt and impurities. Although it consumes a lot of energy, desalination technology is becoming increasingly efficient and gradually reducing pressure on the environment. Besides desalination, the UAE also applies the method of reusing wastewater. In major cities such as Dubai and Abu Dhabi, a large amount of water after domestic use is collected, treated, and reused instead of being completely discharged. Here, wastewater is passed through multiple layers of treatment, from ultrafiltration membranes to disinfection with ultraviolet light and ozone, in order to remove bacteria, impurities, and harmful components. After this process, the water can meet the standards for reuse in greenery, urban landscapes, desert plantations, and some suitable agricultural areas. By 2020, the UAE had more than 75 municipal wastewater treatment plants, with a total capacity of more than 2 billion liters per day. It is this combined network of desalination, water reuse, and water-saving irrigation that has helped the UAE reduce pressure on natural water sources. Although it is not yet a fully circular system, this is still one of the most ambitious water management efforts in an arid region, where every cubic meter of water must be calculated, treated, and distributed with very high precision. Once water resources had been better controlled, the UAE began solving the next challenge: how to grow crops without fertile soil. The clearest answer lies in Bustanica, a giant vertical farm located near Dubai World Central and Al Maktoum International Airport. With an area of more than 330,000 square feet, equivalent to the size of more than 4 standard FIFA football fields, this is a project worth about $40 million and is considered the largest hydroponic vertical farm in the world. Inside this facility, the entire vegetable growing process is brought into a closed environment, where plants do not need soil and do not depend on rain, sunlight, or seasons. Seeds of lettuce, kale, and spinach are placed into chopped coconut fiber growing media by a pneumatic seeding machine with millimeter-level precision. After germination, the young plants are transferred to stacked growing trays, forming layers of green vegetables stretching throughout the building. Beneath each tray, a pumping system delivers nutrient-rich water directly to the roots, then collects, filters, and circulates it back again. Here, instead of sunlight, Bostanica uses a network of more than 20,000 specialized optimized spectrum LED lights, helping growth speed become 3 times faster than in open fields. Thanks to this operating method, to produce 1 kilogram of vegetables, the hydroponic system here needs only about 15 liters of water, while traditional outdoor farming may require more than 300 liters. When the vegetables meet the required standards, they are sent directly into a clean processing area to be cut, inspected, sorted, and packaged. With a capacity of more than 1 million kilograms of leafy greens per year, equivalent to about 3 tons per day, Bostanica is gradually affirming its position in the clean vegetable market and the international high-tech agriculture sector. In arid conditions where summer temperatures can exceed 40 degrees Celsius and fresh water is always a precious resource, the date palm has long been seen as a symbol of survival on the Arabian Peninsula. Its strong root system helps the tree anchor deep into the ground and withstand heat well. For the people here, dates were once an energy-rich food source for nomadic tribes, a familiar food during Ramadan, an ingredient in traditional cuisine, and also a gift that expresses Arab hospitality. This country has more than 40 million date palm trees, with a very diverse genetic stock, reaching hundreds of different varieties. However, making a date palm garden highly productive in the middle of the desert is not simple. Each tree still needs to be planted and watered properly, pruned regularly, protected from pests and diseases, and harvested at the right time. Date palm flowers do not self-pollinate effectively by wind or insects on a large scale. In the past, farmers had to climb each tree to tie male flower branches to the female flowers. Today, large farms in Al Ain use spraying systems. After being collected, male pollen is dried, moisture-treated, and loaded into fine mist sprayers. When the harvest season arrives in summer, specialized date harvesting machines move in. This machine has a giant hydraulic clamp covered with thick rubber padding to protect the tree trunk. The clamp grips tightly around the base of the date palm, then activates a high-frequency shaking system. After leaving the garden, the fruits are taken to the factory to be cleaned, sorted by size and quality, and then processed depending on each product line. Beautiful, uniform, and high-quality fruits are usually packed whole for direct sale, serving the domestic market, tourists, or major holidays. Others are dried to extend shelf life, making them suitable for long-distance transportation and export. For more premium product lines, dates are pitted, stuffed with nutritious nuts, coated with chocolate, or arranged in luxurious gift boxes. Amid the scorching sands of Abu Dhabi, Pure Harvest's Nahil Farm is considered one of the UAE's first high-tech commercial greenhouses. Instead of allowing crops to directly face intense heat, blowing sand, and harsh humidity, the entire pressure of the desert is transferred to the operating system inside the greenhouse. The premium glass imported from Europe is coated with anti-reflective nanomaterial, helping light transmission exceed 90%, while also diffusing sunlight to reduce heat spots that could burn the leaves. Inside this facility, tomatoes are not grown in soil, but develop in a precisely controlled hydroponic environment. The core technology lies in shifting the full pressure of the desert from the crops to the operating system. The plants do not have to fight high temperatures, water shortages, or climate fluctuations on their own. Instead, sensors and machines continuously measure the environment inside the greenhouse. Water is delivered to the roots according to exact demand. Nutrients are mixed according to formulas. Airflow is directed to limit fungal diseases, and the natural sunlight of the desert becomes an advantage instead of an obstacle. By 2025, Pure Harvest said that its farms in the UAE could produce more than 15,000 tons of fruits and vegetables each year. For tomatoes in particular, this is an important test because this crop is very sensitive to temperature, humidity, and light. If stable productivity can be maintained in the middle of the desert, it shows that the climate control system is precise enough to expand to many other crops. This model also helps reduce dependence on pesticides by using beneficial insects to protect plants inside the greenhouse. As a result, the UAE not only shortens the food transportation distance, but also creates a fresher, safer local supply of fruits and vegetables that can compete with imported goods right in the domestic market. But behind the modern picture of vertical farms, smart greenhouses, and other projects, the UAE still faces one very major weakness. It may be able to control the desert, but it has not yet fully mastered core technologies and crop seed sources. The UAE's high-tech agricultural revolution did not simply begin from an idea of protecting the environment. It was strongly driven by a series of shocks from the modern world. During the 2020-2021 period, the COVID-19 pandemic disrupted countless air routes, sea routes, and global food supply chains. For a country that has to import 90% of its food like the UAE, this was not just about vegetable prices rising or supermarkets running short of goods for a few days. Then, from 2022 to 2024, the conflict in the Black Sea region and instability along the Red Sea shipping route continued to reveal one very clear truth. Food does not only pass through farms, but also through seaports, container ships, air routes, and international trade corridors. If these routes are blocked, containers of vegetables and fruits from Europe or grain from major production regions may not be able to arrive. It was these shocks that forced the UAE to look at agriculture through a completely different lens. Growing vegetables in the middle of the desert was no longer an expensive experiment designed to impress the world. It became part of national security. In the 21st century, a wealthy country does not only need a strong military, large seaports, or massive oil reserves. It also needs the ability to produce food domestically, so that it does not depend on imports. Therefore, when the UAE accepts the extremely high cost of developing closed farming systems in the middle of the desert, its goal is not only to sell bunches of green vegetables at competitive prices. It is to build a layer of survival insurance for the country during times when global supply chains fall into crisis. However, after solving the production challenge, the UAE immediately falls into a new technological paradox. It has escaped dependence on nature, but has locked itself into 100% dependence on Western and Japanese core technology corporations. Behind the modern appearance of mega-farms such as Botanica or Pure Harvest is a fairly clear truth. The UAE has not yet created all of the core technologies itself, but is mainly importing and assembling advanced systems from abroad. Although UAE agriculture has still not fully mastered core technologies, crop seed sources, and many essential links in the modern agricultural chain, it is precisely within those limitations that its story becomes even more remarkable. Because the UAE did not begin from a favorable land, it had to begin from a hot, arid land, lacking fresh water and almost unsuitable for traditional farming. Therefore, the UAE's journey also shows the ability of humans to conquer nature through strategy and long-term vision. For more than a century, coal was once the energy backbone of the United States, lighting cities, pulling trains, powering electric plants, and helping build the modern industrial economy. At its peak in 2008, the U.S. produced around 1.2 billion short tons of coal. But as many coal mines shut down, what remained was not only the memory of an energy era, but also landscapes that had been torn open, stripped of topsoil, exposed to landslide risks, water pollution, and left almost impossible to farm in the conventional way. After the Surface Mining Control and Reclamation Act of 1977, the United States began restoring abandoned coal mines on a large scale. To date, this program has reclaimed more than 285,000 acres of mine land, addressed over 27,000 dangerous mine portals and shafts, and stabilized millions of feet of high walls at risk of collapse. But what is remarkable is that, when treated properly, some lands once considered useless can become pastures, forests, lavender farms, energy crop fields, or high-tech greenhouses. Places that once drew energy from underground are now being used to create life above ground. But to make that happen, humans have had to almost rebuild life from scratch. To turn a coal mine into a farm, humans do not begin with seeds, but by repairing both the landscape and the soil foundation. After mining, the site is often left with deep pits, waste piles, unstable slopes, and chaotic rainwater runoff. If these problems are not addressed first, just a few heavy rains can cause erosion, landslides, or wash away the newly restored layer of soil. That is why engineers have to use bulldozers, excavators, and topographic maps to lower steep slopes, level waste piles, stabilize the ground, and direct water into drainage channels, settling ponds, or biological treatment areas. This is not simply about making the landscape look better. It is about preventing the land from continuing to destroy itself after mining. But a stable surface is still not enough. For plants to survive, the soil beneath must be brought back to life. In agriculture, just a few dozen centimeters of topsoil can determine whether crops can grow or not. According to the USDA, just 1% of organic matter in the top 6 inches of soil can hold about 27,000 gallons of water per acre. Yet in coal mines, this valuable layer is often stripped away, mixed with rock fragments, or compacted by heavy machinery to the point where plant roots can hardly penetrate it. So workers must test the pH, reduce compaction, add compost, organic fertilizer, agricultural lime, and deep till the soil so that water, air, and roots can enter. At first, they usually do not plant vegetables, fruit trees, or commercial crops right away. Instead, they use grasses, legumes, or pioneer plants to hold the soil in place, cover the surface, and bring microorganisms back. Little by little, a land once considered dead begins to find a new rhythm of life. But even after the soil has been restored, there is still one thing that can silently destroy every effort at recovery. On former coal mine land, water is not only a source of life, but can also be the greatest danger. When rainwater or groundwater flows through rocks containing sulfur minerals, it can create acid mine drainage, highly acidic water that carries iron, aluminum, manganese, and many other metals. In Pennsylvania alone, more than 5,500 miles of rivers and streams have been affected by abandoned mine drainage, showing that this problem is not limited to just a few small mine sites. What makes acid mine drainage so alarming is that it can quietly seep out from rock cracks, flow through waste piles, and then turn entire streams an orange-red color, like rust. For agriculture, it can make the soil too acidic, weaken plant roots, cause metals to accumulate, and make food crops unsafe. That is why, before turning an old mine into a farm, people must test the pH, heavy metals, surface water, groundwater, and the direction of water flow. To treat it, projects can use settling ponds, limestone channels, constructed wetlands, or acid neutralization systems. The cost is not small. In Missouri, reclaiming abandoned coal mine land can cost around $2,000 to $9,000 per acre. But if this step is skipped, every later effort to grow crops could fail. One of the most practical ways to reuse reclaimed coal mine land in Appalachia is to turn it into pasture or hay production land. It may sound simple, but it makes a lot of sense. Grass tolerates poor soil better than vegetables and fruit, covers the surface quickly, and helps keep the soil from being washed away by rainwater. One study found that more than 80% of reclaimed surface coal mine land in Appalachia had been converted into pasture or hayland. Species such as tall fescue, orchard grass, clover, bird's foot trefoil, or alfalfa are often used depending on soil conditions. Clover is especially useful because it can help add natural nitrogen to the soil. Once the grass cover becomes stable, farmers can bring in cattle, sheep, or goats for controlled grazing. Grass roots hold the soil in place, livestock manure adds nutrients, and the old mine site gradually shifts from a forgotten landscape into a working production system. Places where coal trucks once moved back and forth can now become grassy slopes for grazing animals. And once grass has proven that mine land can come back to life, some projects begin betting on higher value crops. Among the agricultural models on reclaimed coal mine land, lavender does not only create the most beautiful image, it is also a very calculated choice. This plant prefers well-drained soil, does not need soil as fertile as vegetables or fruit crops, tolerates dry conditions, and can be harvested for many years after it takes root. That makes it suitable for mine lands that have been treated but are still not ideal enough for food crops. In Boone County, West Virginia, Appalachian Botanical has planted around 70,000 lavender plants on 35 acres of reclaimed coal mine land. The way lavender is grown here is not simply a matter of sowing flowers on old ground. The site must be reclaimed, planting beds must be shaped for good drainage, weeds must be controlled, varieties suited to the Appalachian climate must be selected, and the flowers are then harvested at the end of the season to distill essential oil. Some lavender varieties can grow back after harvest, allowing the farm to produce across multiple seasons instead of just one short crop cycle. The real value lies in the fact that lavender is not sold only as flowers. According to ATRA, 1 acre of English lavender can produce about 300 to 1,800 pounds of dried flowers, equal to around 12 to 15 pounds of essential oil. Some lavender varieties can reach 53 to 67 pounds of essential oil per acre. When it enters a product chain such as essential oils, soaps, lotions, fragrances, and lavender honey, its value becomes far higher than selling raw material alone. So on old mine land, lavender is not just a flower. It is a way to turn a land once left behind into a product, a brand, and a story of rebirth. But not every form of revival needs to quickly create a product. Some lands need a longer, slower, and more sustainable future. Forests. Before many parts of Appalachia became coal mines, this region was once covered by vast hardwood forests, with oaks, tulip poplars, black cherry, pines, and many native species. But after mining, if the land is only covered with grass to prevent erosion, the landscape may turn green again quickly, while the forest ecosystem may not truly recover. That is why the forestry reclamation approach was created. Not only to green former mine land, but to create the conditions for real forests to return. Species such as white oak, red oak, tulip poplar, black cherry, black locust, Virginia pine, or shortleaf pine can be planted depending on the region. According to FRA guidelines, the rooting material layer should be at least about 4 feet deep, because trees need space for their roots to grow downward, absorb water, and withstand dry seasons. The scale of restoration is also very large. In 2007, states under RE reported planting around 12.8 million trees on minelands, but only about 3.4 million of those trees were planted following the full FRA steps. What is worth noting is that reforesting mineland is not the story of a single growing season, but an investment that lasts for decades. A young oak tree today may not generate profit right away, but it marks the return of living soil, shade, birds, and future timber value. But for sites that are still too risky for direct planting, humans have found another path. Not planting into the mineland, but farming above it. For places where the soil is still not safe enough for direct planting, humans choose to lift agriculture above the ground. Greenhouses can be built on stabilized mine sites, while crops grow in clean substrates, hydroponic systems, or drip irrigation systems, separated from the mined soil beneath. Thanks to this, tomatoes, lettuce, cucumbers, strawberries, or herbs can grow in an environment where water, nutrients, temperature, and pests are carefully controlled. According to the USDA, controlled environment agriculture systems such as hydroponics and vertical farming can use up to 90% less water than traditional farming. Near Appalachia, the App Harvest greenhouse in Kentucky covers about 60 acres and was once considered one of the largest greenhouses in the United States, using hydroponics to grow tomatoes with far less water than open field farming. But greenhouses are not magic. They reduce the risks from the soil, but they still require large capital investment, high energy use, and complex technical operation. So the future of former mine lands is not only about what crops to grow, but about choosing the right model for each piece of land. But as more solutions appear, one truth becomes clearer. There is no single formula for every old coal mine. Not every land that was once mined for coal can be turned into cropland, pasture, or a greenhouse site. Some places have water that is too acidic, soil containing heavy metals, terrain that is too dangerous, or treatment costs that are too high. In Missouri alone, reclaiming 1 acre of abandoned coal mine land can cost around $2,000 to $9,000. And that is only the basic reclamation cost, not including future agricultural operation. So success does not come from choosing a beautiful crop and planting it into the ground. It comes from choosing the right future for each piece of land. Some places are suitable for pasture, some should be reforested, and others should only become retention ponds, ecological parks, solar energy sites, or conservation areas. For directly consumed crops such as vegetables, tubers, and fruits, the requirements are even stricter. Soil and water must be tested regularly to avoid risks from low pH, heavy metals, or residual pollution. That is why a farm on former coal mine land is not simply an agricultural project. It is an environmental, technical, economic, and food safety challenge all at once. And when seen from that perspective, successful projects are remarkable, not only because they can grow crops, but because they choose the right way for a damaged landscape to come back to life without creating new risks. Turning reclaimed mine land into farms cannot replace the entire coal industry, but it can open up new value chains. Land restoration, grass planting, livestock grazing, lavender farming, essential oil distillation, beekeeping, greenhouse operation, ecotourism, and forest restoration. The U.S. AMLR program, created to turn former mine sites into drivers of economic development, has allocated more than $1 billion since 2016 to coal region states and tribal communities. So this is not only a story about land, it is the story of towns searching for their next chapter. A region once known for coal can begin to be remembered for pastures, young forests, honey, lavender essential oil, or high-tech greenhouses. That is not about erasing the past, but about using the old ground itself to build a different future.